Hey everyone, we're going to get started today with AP Calculus's, AP Calculus BC's questions involving series. And this is the major skill that happens in Calculus BC. So I like to say that if you're really interested in getting your 5 in Calculus BC, you've got to pay attention to this series problem because this is basically where your points are coming from. So let's take a look at the series problem as I have it. Okay, these problems are going to come to us via Tokyo Drift, which is a movie in the Fast and Furious franchise. You can basically read through all this stuff yourself, but here is a situation that I have us modeled with. In order to maneuver the car around a hairpin turn, Sean estimates that his car needs to maintain a distance from the outer wall modeled by the function f of t. You have a bunch of derivatives. And it's given in meters, and t is seconds from starting the turn. So part A, you're going to write a third degree Taylor polynomial. Part B, write a second degree Taylor polynomial for f prime, and you're going to use that polynomial to estimate f prime at 0.5. Also, you're going to explain that in context. Part C, you're going to write a second degree polynomial to estimate the integral. You're going to use that integral to estimate some other quantity which involves an integral and a quotient. And then you're going to explain that in the meaning of the problem. And finally, let's say that we know the fourth ordered term of the polynomial. Can we figure out the fourth ordered derivative evaluated at 0? So these are all pretty standard questions that you would see on any AP test. Maybe not all of them at the same time, but these are definitely question types that you'll see on the AP test. So one or more of these will be there. Part A, write that third degree Taylor polynomial. So the idea here is if you don't have that Taylor theorem memorized, if you don't have the construction of a Taylor polynomial memorized, you got to turn around right now and just memorize that. So this part really is just substitute numbers. So this first part we've got here is that Taylor polynomial. This is what they all look like. Notice that you evaluate derivatives at some letter A. We call that letter A the center of the polynomial. And then there's also the factorial factor. That sounds redundant, but yeah, factorial part. 1 over 2 factorial, 1 over 3 factorial. And actually they all have them. Even that first one is 1 over 0 factorial. 0 factorial being equal to 1. And then that second term is 1 over 1 factorial. So you really can think of it as 1 over n factorial. Now that you have the basic Taylor polynomial format, you are going to, you're going to go ahead and substitute the values that you know. So I think the first thing that we're going to do here is we're going to substitute 0. Yeah, we substitute 0. And that's my value of A. The only thing I have, other thing I have here is instead of an x, we're using a t. And since we have x minus a, that's really t minus a, which is t minus 0. There's no need to write a t minus 0, so I'm just writing t squared, and t cubed. You can see that here, here, and here. Okay, really the next thing left to do, or the only thing left to do now, is to substitute those values of f0, f prime 0, and f double prime 0. And that gives us this. So here we go. You might want to simplify that out. Notice that all I did was substitute the values that came with the problem. The f0, f prime of 0, f double prime of 0, f triple prime of 0. And then now a simplification. Remember, the simplification here is just a multiplication, so it is viewed as an optional simplification for you. So here's that simplification. And that solves it. The other thing that you might want to think about is, since I'm only using a piece of the series, just a polynomial, that's how come you're seeing approximately equal sign and not exactly equal sign. Whenever you truncate that polynomial or the series to create a polynomial, it is appropriate for you to use the not equal sign. I don't think anyone's going to mark you off on the AP test necessarily, but it is something that you should have in your mind. Definitely highly cultivated students will know that as well. Moving to question 2, now we're supposed to write a second degree Taylor polynomial for f prime about x equals 0. Then we're going to use that polynomial to estimate and then explain what that estimation means. Here is that derivative. The idea here is that you want to take what's called a term-by-term derivative. Okay, so you're taking the derivative of 1, taking the derivative of negative 4/5 t, taking the derivative of negative t squared, and taking the derivative of 1/2 t cubed. Do them all separately. This is just a polynomial, and you've integrated plenty of polynomials by the time you've reached this part of the AP course. So taking the derivative of every term, we just get this. And there's nothing exotic about this. Notice the first term is going to cancel out, not cancel out, but the derivative of 1 is 0, so there's no need to write that. Where is my cursor? Oh, there we go. The derivative of 1 is 0, so we didn't write that. The derivative of negative 4/5 t, that's just negative 4/5. Having a hard time writing. But yeah, there's nothing exotic about this problem at all, really. It's just a derivative of a polynomial. Next, if you want to estimate f prime of 0.5, all you're doing is substituting 0.5. So let's substitute 0.5. Okay. I've turned everything into a decimal just to kind of help me calculate. Most of the time when you take the AP test, this is not going to be on the calculator section. So leaving this polynomial like this would be accepted. There is no problem with that. It's all just multiplication and addition and subtraction at this point. If, I don't know, if you feel like that's incomplete and you feel compelled to simplify that, by all means do that, but only do that if you have nothing else to do on the AP test. You don't want to waste your time making a correct answer more correct, or heaven forbid you make a correct answer incorrect. We don't want you to do that at all. So what is the meaning of negative 1.425? If you take a look at what this is, you're looking at the derivative. So the derivative represents a change. This is the change in f. More specifically, when t equals 0.5, f is changing by a rate of negative 1.425. All you got to do is put some context into that and, of course, some units. So when t equals 0.5, Sean's distance from the wall, remember, distance from the wall, that is the interpretation of f. F is a distance from the wall. So Sean's distance from the wall is decreasing. It's decreasing because that rate is negative, of course, and by a rate of 1.425. Whenever you say decreasing, the rate is going to stay a positive number. So we're decreasing at a rate of 1.425 meters per second. Meters being the unit for f, per second being the unit for t. Okay, so there we go. There's our question B. Part C. Use your polynomial in part A to write a second degree polynomial for the integral of f of t. Use this polynomial to estimate 1 over 0.5 minus 0 over the integral from 0 to 0.5 of f of t, and then explain the meaning of that expression. So just like with the derivatives, the integral is going to be a term-by-term integration. and it's going to be a term-by-term integration of the polynomial. So when you take a look at that, the other thing to think about is you want a second-degree polynomial answer. So when you integrate, you only need to put in the first-degree term, because when you take the derivative of, or the integral of a first-degree term, you're going to get a second-degree term, and that's going to work nicely with what you want to do. You don't need any extra terms because no one's asking for any extra terms. So again, this is a term-by-term integration, so the antiderivative of 1 is x. The antiderivative of 4/5 x is 2/5 x squared. And we're evaluating from 0 to t. We're putting in basically those upper and lower limits. And then when you substitute 0, this evaluates to 0. And when you substitute t, you're basically just changing the x's to t. So this is that second degree. So notice that if you want to evaluate this integral, if you put a number here for t, all you got to do is put that same number in for the t's in the polynomial. So when I take a look at the next part, and I want to integrate this part, I am substituting 0.5, so I'm going to put evaluate this when t equals 0.5. So I'm basically just going to substitute 0.5. And when you do all this mathematics, you're going to get 0.4 as your result. Maybe I should show that calculation. So there's the calculation. And of course, 0.4 is our correct response. Now that I have that, I know that integral evaluates to 0.4. The expression that we're supposed to evaluate is actually this one. And that simplifies to that doesn't simplify. All you need to do is take the answer that we got in that line 3 right here and multiply that by 1 over 0.5, and you get 0.8. Now comes the task of saying, what is that 0.8? If I take a look at this formula, that is an average formula. That's how we take the average in any calculus class. So this is an average value of f from t equals 0 to t equals 0.5. Well, what is f? F is the distance of the car to the outer wall. So the average distance to the outer wall is 0.8. So in the first 0.5 seconds, Sean's average distance from the wall is 0.8 meters. And that's it. Not really that difficult once you understand what you're looking at and once you see that that is an average. Letter D says, suppose that it's known that a fourth ordered term for f about x equals 0 is negative 11 over 6 multiplied by x to the fourth. Either give the value of the fourth derivative at 0 or explain why it cannot be determined. So the first thing I want you to think about is you can determine this because if the center of the polynomial is 0, as expressed right here, that means that any polynomial expression should contain derivatives of 0, or derivatives evaluated at 0. Those two match, so you can figure out the value of the derivative. Now, if they didn't match, say this was 0 and this says, what is the fourth derivative at 0.1? Then we couldn't do anything about that. We don't have any information about derivatives other than the derivatives at the center of the polynomial, which in this case is 0. So since these two match, 0 and 0, we can figure this out. And the way to figure this out is to make sure that you have your Taylor polynomial recipe memorized. if you haven't memorized, you know that the fourth ordered term is given by an expression that looks like this. 1 over 4 factorial, fourth derivative evaluated at a, x minus a to the fourth power. We know what a is. A is 0. So we substitute 0 and we get this lovely expression. Now that I have this expression, I can clearly, those x to the 4's match. So that means that their coefficients also have to match. So 1 over 24 multiplied by the fourth derivative at 0 has got to be equal to 11 over 6. And if that's true, then one real simple algebraic maneuver is going to give me the fourth derivative. I just have to multiply by the reciprocal. That's going to get me 44. So the value of the fourth derivative is negative 44. And that's it. Not bad, right? Notice that you do have to have mastery of that Taylor polynomial. If you don't know what that Taylor polynomial or how to construct a Taylor polynomial, these problems really can't do anything for you. You have to have some facility with derivatives and integrals. No one's going to do those for you. And the quicker and easier it is for you to integrate and differentiate, then the easier time you're going to have with these problems. So that being said, let's take a look at the box. Here are our important ideas. Of course, it starts off with how do you construct a Taylor polynomial? How do you construct a Maclaurin polynomial? And also, there's that thing that I was saying earlier. If the function is exactly equal to a whole series, that means the function is only approximately equal to a truncated form of that series, which is another way of saying that the function is only approximately equal to a polynomial. So differentiation and integration get done term by term, and remember that your variable of integration and differentiation, it's never n. So don't integrate an n. I don't want to see 1 over n plus 1 to the n plus 1 power. That doesn't happen, okay? It's your variable is not going to be n. It's either going to be x or t, maybe theta, I don't know. If you need to approximate anything in this whole series domain or this series concept, approximation just means you're substituting into a polynomial and not substituting into a whole series. And of course, if there is those questions where you're supposed to figure out the value of a derivative, chances are you just have to set the appropriate term of the Taylor polynomial equal to whatever you have. So if they want the 10th, if you see a 10th power, then it's going to be equal to 1 over 10 factorial f to the 10th power evaluated at a multiplied by x minus a to the 10th power. So take a minute to copy these down, and we will take a look at the check your understanding in a second. Let f be the function defined by f of x equals e to the negative x squared. Part A, write the first 4 non-zero terms and the general term for the Taylor polynomial for f about x equals 0. B, use your answer in part A to find this limit. And part C, write the first 4 non-zero terms of the integral and then use the first 4 terms to estimate. So these are all things that we have done already, and they are all on the same problem. So let's take a look at part A. And in part A, you need to have the series for e to the x memorized. I didn't talk about it, but there are at least 4 series that every Calculus BC student needs to have memorized. E to the x is one of them. 1 over 1 minus x, that's another one. Sine of x, and cosine of x are the other two. There are other series that people recommend that you memorize, but you're not going to get anywhere if you don't memorize those 4 basic series. Make sure you take a look at them. I know I have them written under series problems under the blank non-answer key version of this. So from here, you're going to, through multiplication and substitution, you're going to create e to the negative x squared. So for this one, all you really need to do is substitute negative x squared for x. So here I've taken every instance of x and I've substituted it with negative x squared. I'm being very careful with the algebra here. Make sure that the negative x squared is always in a parenthesis, because I'd sure hate to get this problem wrong because of an algebraic mistake. Simplifying, you get this, which I believe is the answer to this. Remember that when you square the negative sign, you're going to get a positive. When you cube the negative sign, you're going to get a negative. This is where the algebra will go wrong. The other place where some students kind of feel uneasy is dealing with this general term. So a couple of hints that you might want to think about. If I have negative x squared to the n, this negative is the same thing as negative 1. Since that's negative 1, that's this negative 1 that you see here. That's this negative sign. So that's negative 1 to the n power. Of course, the n power here matches the n power here. Always try to separate out this. It will make your life easier should you use this polynomial for other things. Now, the other part of this is x squared. X squared to the n power is x to the 2n power. Remember, a power of a power means you multiply. Maybe I should write it like this. Negative x squared to the n power. That's the same thing as negative 1 multiplied by x. Whoa, that's not what I meant to do. Negative x squared. That's the same thing as negative 1 multiplied by x squared, everything to the n power. And of course, you can take that power and give it to each one of those factors. And x squared to the n power is x to the 2n. So that's where all of that stuff comes from. And you'll see that here and here. Okay, so letter B. Okay, so for letter B, we're asked to evaluate this kind of a strange looking limit. And here is what it looks like. We're evaluating this limit, and the first thing that you want to do is, you see f of x there. Don't put the function in, put in the series. Okay. Chances are things are going to, how do I say this, are going to simplify. Especially if you notice, and let me make sure that I'm on this correctly. If you notice that this right here, 1 minus x squared, you notice that those are the first two terms of this series of f. So it makes sense to substitute f based on that fact. So substitute that, do a little bit of algebra. Here I've just kind of opened up those parentheses, and look at that. The first two terms of the series, they're going to cancel out, leaving me with a series that looks like this. Now, that may or may not look nice to you. It looks pretty good to me because, as I'm reading this, I see that the x to the fourth in the denominator is going to cancel out 4 powers of every term. And then every term of that numerator, starting with that 4th degree term, is going to have at least 4 powers of x, because as we know, in a series, the power of x is only going to increase. So, if you cancel out that 4th degree power, you get left with this polynomial x negative 1/2 plus x squared, or 1/6x squared, and of course every term after 1/6x squared is going to have an x. You can just substitute the x equals 0 at this point. So when I substitute x equals 0, I get 0. No, I don't get 0. I get negative 1/2. So this series is equal to negative 1/2. Let's take a look at letter C. C says to integrate e to the negative t squared dt. Now, when you're on the AP test, there's never going to be any what we call difficult integrations. And this would definitely be a difficult integration. You can try a u substitution, and that negative t squared is never going to balance out. So there is a little bit of wisdom here in knowing functions that you can integrate and functions that you cannot integrate. So we've just substituted the series into the integral, and it's always easier to integrate a polynomial than it is to integrate some kind of a transcendental function. Integrating that polynomial is actually not all that crazy. I think I said it earlier, you've integrated all sorts of polynomials by now, so you should know the rules. The only thing that I can mention here that hasn't been mentioned or by me already is that nowhere did it say in the problem that you needed to integrate the general term. It just says the first 4 non-zero terms. Take a look at that here. The first 4 non-zero terms. So if it doesn't say to do the general term, don't do the general term. You're wasting your time, and those minutes that you spend integrating that general term could probably be best used somewhere else. So here we go with our antiderivative. All that's left now is to substitute x and to substitute 0. When you substitute 0, you're going to get a 0 because every term has a t in it. Here we go. T, 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 t. Every time, if you substitute a 0 for those t's, you're just going to get a 0. When you substitute the x, you're just going to change all those t's to x. So here is that antiderivative. Not bad, right? For the next part, it says to use the first 2 terms to estimate this integral. Use the first 2 terms. And this integral here is the exact same thing as this integral up here. The only difference is this says 1/2 and this says x, which says to me that in the antiderivative that I have here, all I need to do, it's actually the integral, but in the integral, all I need to do is substitute x with 1/2. Substitute the 1/2 and you get 1/2 minus 1 over 24. And I should mention at this point, you could leave that answer. This is, chances are, in the no calculator section, so you're not required to do any arithmetic here. But we're just going to simplify that one more step. And you get 11 over 24. So that's it. That is all of the AP Calculus for this series that we're going to do. Really, I know that this isn't nearly everything that you'll need to know for series, so make sure that you're studying these Remember, the quickest way to a 5 on the AP Calculus BC is to know your series really well. Okay, I'll see you guys next time.